Hello everyone, and welcome to another episode about GCC Obfuscation plugins. In part 1, we looked at the Goat project and in particular at the jpanic plugin, which generates junk instructions and functions and places them throughout the code. We analyzed a few binaries dynamically with GDB, debugger, and statically in add-apt-pro. In this part, we'll look at another plugin called Munger, which will obfuscate strings. It will actually simply encode them and generate a decoder. All happens nicely at runtime. It will call the decoder before usage and save the result in a global variable. As before, let's clean the working folder to start from scratch. So, first thing, we need to build the plugin itself. Simply issue the make command. Okay, we also have a test file here, which contains a lot of global strings, functions printing some other strings, and even more strings here. Let's check the README file to see how to compile and link this. The command we need is this one. We have an error. The code cannot find the decode function. Let's see what's happening. As we can see here, the decode function is located in munger_builtin.c file. We have the file here already generated, so let's double check using nm-tool, which lists symbols in ELF binaries. Okay, the T letter here means that the decode function is located in the text section. This is the code section of the library. Next, we'll recompile the test program, but this time also link against the library that contains the decode function. This trick with nm-tool is very useful to troubleshoot compilation errors like this. Great, it compiles successfully. And it also prints everything as expected. Let's see how this looks in a disassembler. Switch to the analysis VM and retest to make sure the programs run correctly. We'll start with GDB for a quick look through the code, then move on to IDA for more heavy static analysis. Set up a breakpoint in the main function and run the code. As we can see here, ASCII strings are stored encoded, then the decode function is called to obtain the plain text version. Take a few moments to look at the code, then skip through a few instructions. We could step inside the decoding functions, but we'll do this in IDA in a moment for clarity. For now, notice that after the decoding function is called, EAX register should point at the output string. Let's print both the value of the EAX register, then print the memory bytes from that location as a string. As expected, here's our first decoded message. Load the file in add-apt-pro to have a better picture. We will investigate also the encoding and decoding part. Okay guys, that's interesting. We have a pattern here. An address of a global location is retrieved into the EAX register, then another value representing the length is passed into edx. Then there's an offset, probably to the encoded string, then another pointer and a call to the decode function. The pattern is the same for all the strings, not exactly very stealthy, but it does the job of hiding all the strings in the application. Let's have a look inside the decode function. Notice the three parameters: the decoded string, the original, and the length. If we follow through the code, the decoded one will contain a pointer to a memory address allocated dynamically. It will be constructed one character at a time. The variable I here represents an index from 0 to the length of the input. This small block is actually the decryption routine. Let's rename it as such. We'll see later that it's not actually decryption, but a simple operation. For each byte in the input string, these are the operations that will be applied. Looking closer, it's clear that each byte is simply negated. This was pretty simple. There's no encryption at all. This is just a proof of concept. I'm curious where and how this is defined. It should be in the Munger_builtins.c file. Let's see what's happening. Each character is decoded by simply XORing it with the value -1. Think about it. This is equivalent in assembly code with applying the NOT operation on the byte. This is not very complicated, but the algorithm could definitely be changed. Think about possibly adding encryption with a system-dependent key. This would definitely complicate the analysis. If you like this episode, check the previous video and play with the other plugins in the Goat project. All of them have something interesting to show. That's all, folks. Thank you very much for watching, and please subscribe to our channel to help us create more videos. Cheers!